Hey guys, so I just filmed an entire 30-minute video and it wasn't actually recording. I swear it wasn't my fault, but anyway, so this was everything that I spoke about for no reason. So let's start again. First thing I want you to write down is basically we're working with two formulas today. Okay, so let's call it, so we're integrating powers. The heading today is integrating and the first thing we're going to look at is, let's call it formulas. These are the formulas you already know and you've already seen before in both 2 Unit and Year 11 Extension 1. So you got your Pythagorean identity, sine squared a plus cos squared a equals 1, and then you have your double angle formulas. You've got two double angle formulas, but there is one that we're just working with today, and that is cos 2x equals cos squared x minus sine squared x, which your other one is, it's just for the sake I will write it out, 2 sine x cos x. So there's your formulas that we are looking at today. Now, a couple of things with those formulas. We know that our Pythagorean identity can be also written as this: sine squared a equals 1 minus cos squared a, or cos squared a equals 1 minus sine squared a. The thing is though, let's have a look at how else we could write our cos double angle formula. Let's go down here actually. So, we know that sine squared a is equal to this, whether it's an x or an a. I probably could have used a's here instead, but anyway. So let me make that substitution. Now I get this, that cos 2a is equal to cos squared a minus 1 minus cos squared a. Notice the bracket I put there so we don't get our negatives mixed up, which simplifies to this: cos 2a is equal to, double negative makes it positive, so 2 cos squared a's minus 1. What if I did the other substitution? So start with my formula, cos 2a, but instead of substituting what sine squared a is, why don't I substitute in here for cos? So then I would get cos 2a is equal to 1 minus sine squared a minus another sine squared a, which simplifies to cos 2a is equal to 1 minus 2 sine squared a's. So all I've done is made some basic substitutions. Let's rearrange now each one to get the trig squared equal to everything else. So for instance, if I rearrange this, I'd have, bring the 1 over and plus it and divide by 2, I'd have an answer of cos squared a is equal to cos 2a plus 1 all on 2. And this one, if I rearrange to get sine squared equal, I'd have sine squared a is equal to 1 minus cos 2a all on 2. Hopefully you can see that. Now I'm going to put these two formulas we've just created in blue boxes. So when I refer to the blue box, I'm talking about these two formulas. You have some options from here. You can memorize these formulas, which I don't like just doing. I like like when students can show a deep understanding of where things can come from. So you can memorize these two formulas, or yes, you can show where they come from by just remembering basically two formulas. You don't even have to remember them. You get given your Pythagorean identity and you get given your double angle formulas. There's only two there that you need to know, and substitute in each one, rearrange, and you get the two blue box formulas. However, these formulas are now what we're going to work with. So if we got a simple question as the integral of, and this has been in HSC, sine squared x, something like that, and I think it's also in your exercises. Getting something as simple as that, well, it's just a matter of saying, well, hang on, let me do the long way. I'd say to myself, okay, sine squared a plus cos squared a equals 1, and cos 2a equals, is it sine or cos first? Cos squared a minus sine squared a. I just want to make sure okay, good, I'm recording. Okay, so start with the two formulas here, rearrange and make our substitutions. I know that I want sine squared, so I want to get rid of the cos squared, which means rearrange my Pythagorean identity to have cos squared equals. And sub that in to get rid of your cos. So therefore, cos 2a equals 1 minus sine squared a minus sine squared a, which gives us a nice formula we've seen. 1 minus 2 sine squared a. Now, like you can see, this is exactly what we've just done. So then we would rearrange to get sine squared on its own. And when you do that, you get sine squared a is equal to 1 minus cos 2a all on 2. And that's your blue box formula. So like I said, I could have started this question with the blue box formula if I wanted to remember it. Either way, it doesn't matter. You do still need to know how to get to the blue box, but you can just remember your blue box if needed. So then I can say, well, therefore I know that the integral of sine squared x, which is what they want, that's the same thing as just taking the integral of 1 minus cos. Now in this case, a is x in the question, because they are, by definition of the blue box formula, the same thing. And what do you know? I can do the integral of that right hand side. If I take out the half out the front, and now I integrate that. The integral of, that's going to become an x. Integral of cos is a positive sign, 1 over, and you'll get this. There's my answer. That's it. And that has been asked in HSC. So let's do the opposite now. Let's do if the question said, do the integral of cos squared x. Now this time I'm going to do it by jumping straight to the blue box formula, which you can see, yes, it does eliminate half of your working, but like I said, I do like you to show a deeper understanding, and that definitely does show the micro deeper understanding. But let's say we did jump to the blue box formula, which is fine. And the blue box formula says that cos squared a equals cos 2a plus 1 all on 2. So therefore the integral of cos squared x is equal to the dx, the integral of cos and in this case x is just a, 2x plus 1 all on 2. Bring out the half. And what do I get? I get a half outside of cos integrates to positive sign, positive a half sine 2x plus x plus c. And you can expand the half in if you like, but this answer is best it's in factorised form. So there we go. Now in a HSC exam I would do the longer response. However, you're still going to get your marks even if you did do the shorter version. Okay, let's have a look at some trickier ones. Let's say instead of just using x's now, let's say the question had okay, this HSC question. Now this is from 2016, I think it was. Let me find it. Yep, so this is 2016. Question 5. And it asked us to find the integral of sine squared 2x dx. Okay. Alright, two options. Blue box formula or show you working. Because this is a HSC question, I'm going to show how I would do it if it was my HSC. And if it was my HSC, I would start by going, alright, I'm going to show the marker all of my knowledge. I want sine squared, so I'm going to eliminate cos. So I say, well then, cos and sub that in. So I get cos I should be using A's, it's a bad habit. Hopefully you can see where that came from, and then rearrange to get just your sine squared. And that's your blue box formula. Okay, once you've gotten there, you say, well then therefore, my integral of sine squared 2x is the exact same thing as the integral of 1 minus cos 2. Now, in this case, a is 2x. Hopefully you can see that. So 2x is a. So I make my substitution, cos 2 lots of a is 2x, all on 2 dx. Bring my half out, and now it becomes 4x. Now I can integrate. And there's my answer. And that was a HSC question. Okay, so I'm not going to go through this one, but I'd like you to have a go at this was a HSC question. Now, I want you to give that a go. Your final answer, I have written here. You should get an answer of that. So I'd like you to give that a go. That was 2012 HSC. Oops. What I'd like to do is finish off with one of the harder versions in your textbook. So one of the hardest questions in the textbook was, it's not even difficult once you know what you're doing, question 6E out of exercise 511. And the question says integrate 3 sine squared 2x on 5 dx. And I'm going to do this one by jumping straight to my blue box formula, which says that sine squared a is equal to 1 minus cos 2a all on 2. So therefore the integral of 3 sine squared 2x on 5 dx is equal to the integral of, now it's going to be 3 lots of 1 minus cos 2. Now a this time is 2x on 5 all over 2. So I've made that substitution and it's 3 lots of, so it becomes 3 lots dx. Now one thing I'm going to do here is, to make my life easier, I can bring out the 3 on 2 at the front. And it becomes cos 4x on 5. Integrate. Now differentiate the brackets. I get 4 on 5, and 1 over that becomes 5 on 4. And there's my answer. Okay, so give the other exercise questions a go, highlight any you're not sure about, and ask me first week back. I think I want to do a little formative on this stuff towards the end of week 1. So please have a look at the Maths Online, have a look at this, and then do your exercises too.